All right, everyone, welcome to our first CML. I got to think about what this is called. CML practice help session, right? Getting ready for the 2023-24 season. And so we're taking a look at the previous three Continental Math Leagues in Calculus from 2020, 2021, and 2022, and hoping to, no pressure, but defend our title, right? Avon High School 2023 national champions. So joined with a bunch of awesome juniors from our AP program here. So, all right, who wants to start us? You can throw it in the chat. Let's take a look at the first problem that y'all want to take a look at. Don't be shy. Which one do you want to look at? Because if you don't tell me, this is going to be an awfully short session, you guys. So how about 2021? And we'll go to question number 8. I figured you guys are going to ask a whole lot of question 8s, right? Question 7s and 8s for sure. So I want to make sure I verify this is what you're talking about, right? When you say that particular question. And if not, just like holler in the chat. If this is the right one, I'll just go ahead and start talking about it. So the question reads, in terms of A, find the maximum area of a rectangle that may be inscribed in the region bounded by the graph of f of x equal x squared minus a squared squared and the x-axis if one side of the rectangle lies on the x-axis and the other two lie on the graph of f of x. I know that's really very complicated, right? So why don't we set this up with a picture and get a little bit more familiar with what's happening here. So what's essentially going on is you have an XY axis and you've got this curve x squared minus a squared squared. And, let's be honest, nobody knows what that graph looks like, right? Even if the A was known to you, it's probably likely that we would still struggle understanding what this graph looks like. But you know what, guys? We don't need to know what the curve looks like in order to still be able to solve this problem. But you guys are all aware of the fact that you are perfectly allowed to get rid of some things here. You're perfectly allowed to use a graphing calculator on any CML question. And you could conceivably sketch this function, x squared minus a squared, if you wanted to. X squared minus a squared, all squared. And you know that the calculator is going to say, hey, do you want a slider for A? And we'll say, okay, that's fine for right now. And we just basically have this picture that I guess looks like a W, right? And if I were to move that slider to make A change to different values, like maybe 2 or 3, I still get that W, but it's like the middle maximum of the W just sort of increases as time goes on, right? So what do we draw here? That's a great question. Why don't we just draw a very generic W shape that might look like this? After all, we don't have anything on the axes, at least the y-axis, scaled for us. All right? And that gives us a lot of freedom to draw what we want to draw. Okay? So we'll start with this general picture. What we're going to do is inscribe a rectangle. So I'm going to use red here for that rectangle. That's going to be inscribed in the region bounded by the graph and the x-axis, which means that rectangle, you guys, has to be somewhere right around like here. Okay? That's our picture. So this is what we're going to try to find the largest possible area for. Okay, so hopefully that makes sense. Um, I don't think that there would have been anything wrong if the picture would have already been provided, but I don't want to make a big deal out of this W. It doesn't matter what the graph looked like. I just need something that we can start to label. Okay, So I have a question for you all, and it's a question that I think you can all answer. What's the formula for the area of a rectangle? You know it, right? Length times width. And it doesn't really matter which side we want to call the length and which side we want to call the width. That makes no difference. And so what we're going to do, you guys, is we don't know how far over to put the left lower right corner of our rectangle. So I'm going to give that an arbitrary value of x. And then you see this ordered pair right here? That ordered pair that would be the upper right-hand corner of the rectangle would be x comma y. All right. So I'm going to ask a new question, you guys. What is the area formula for the rectangle that you see in this picture that uses x's and y's? How far is it across here? And use symmetry. You want to make sure you use symmetry. So you'd have an x and an x, which makes 2x. And obviously, how tall is the rectangle? It's a y. Okay. Are you with me? All right. So I know you might be sitting here and thinking, okay, what does this have to do with calculus? What does this have to do with anything that we have studied in your class record? What you're going to do is find the maximum value of that function. Just like if that function was a curve, an f of x curve, and you wanted to find out how tall it can go, it's the same idea, okay? It's just that you had to come up with the equation on your own. And you might be sitting there and you might not be real happy that there's a y in this. I'm not either. Let's change that, right? We don't want him. We don't like him. So is there anything that you see in this problem that will allow you to change the y into some other expression that preferably has an x in it? And this is always tough because I don't know if if you guys are seeing that or not, because there's not a lot of interaction and nobody wants to turn their cameras on, and that's totally okay with me. I'm fine with that. I'm not going to force you to do that. But you guys, I hope that your eyes are kind of being drawn to the equation of the W shape, that quartic equation. That's what you're going to do. You're going to swap the y out and you're going to replace it with x squared minus a squared squared. Okay? And now we're going to treat this like a problem that we had just recently, a couple of weeks ago. Okay? So step one, let's take the derivative. Okay, so to take this derivative, you have to make a decision. Is this going to be easier to just do a product rule with a chain, or do you guys want to like FOIL it out? It's really your call. I suppose you could also use your graphing calculator to take this derivative. I'm going to try to talk you out of doing that though. Okay, because sometimes you don't know what kind of form it's going to leave it in. So why don't we use the product rule? So the derivative of 2x is 2. Multiply by x squared minus a squared squared. Add 2x. And then we multiply by the derivative of x squared minus a squared, which is 2. X squared minus a squared to the first, multiply by the derivative of what's inside, x squared minus a squared, would just be 2x. Remember, a is a constant. So we're going to treat it like that. Okay? And if you're wondering, why does the CML do this to us? Why does it give us an a instead of an actual value? To make the problem a little bit more harder, but to also keep you guys from like just manipulating things in a graphing calculator and coming up with an answer that doesn't require a lot of calculus use. Okay, so the next thing that we're going to do is we're going to try to set this equal to 0. because we have to find these things called critical values, right? And so in order to make that happen, I want to look at these two terms very closely. There's one there underlined in yellow, and there's one here underlined in brown. And we're going to pull out the common factor. That common factor would be a 2. And anything else that's in common? Hopefully you see it, an x squared minus a squared to the first. And so if we factor that out, we're going to be left with x squared minus a squared to the first to complete that second power. Looks like we have a plus. And then we already brought a 2 out, so we won't need him. But there's a 2x and a 2x that would make 4x squared. And then this x squared minus a squared's already been factored. And so then we can set that equal to 0, right? And I suppose if we clean that up a little bit, we would get 2 quantity x squared minus a squared times 4x squared minus a squared. All right, now before we start kind of like, oh, Mr. Record, this problem is so hard. If you haven't discovered it by now, problem 8 is usually going to be the hardest problem on all the CMLs. All right, so we started with a doozy here. Thanks, Olivia, for that, right? It's okay. But I figured you guys are going to probably want to know more about these 2-point questions anyway tonight. So how do we solve these equations? Well, we just set the x squared minus a squared equal to 0, and we'll set the 4x squared minus a squared equal to 0. And we just slowly but surely solve it for x, right? And the way that you want to do that, you guys, is probably by factoring, because I'm afraid if you guys add a squared over and take the square root of both sides, maybe you'll forget the plus or minus. Maybe you wouldn't forget it. But either way, you're going to get x as positive a or x as negative a. And then over here, 2x minus a, 2x plus a, set equal to 0. And that's going to give you x being what? A over 2 or possibly negative a over 2. Okay? Oh, wait a minute. Does Mr. Record have an addition problem here? That should be a 5, right? Thank you. Thanks for that, Savannah. I caught it right before I saw the chat. So you know what? That's going to change things just a little bit. It might make this factoring a little bit creepier. So if you don't want to put square root of 5x, why don't we just say this? 5x squared equal a squared. X squared is a squared over 5. So x would be plus or minus the square root of a squared over 5, which we could say a over root 5 or negative a over root 5. Okay? Now, I don't like the fact that we have a gazillion x's here, right? So if we look at this, maybe we could make this a little bit easier. Is there anything in this problem that says that a can't be negative? I don't see anything up here, right? But then at the same time, I look at the expression here, and if a is being squared anyway, does it really matter if a is positive or negative? In essence, it's going to give us the same result. We're going to get that same area equation, right? And remember, here's your area equation right there. And so what you have to do at this point is, I guess we have to sort of take a leap of faith as to what is going to serve as our critical value, okay? And we have a problem with x being a or negative a. We're going to throw those away. And I want to see if you guys understand why. Why can't x be a? What problem does that cause? If X were A, doesn't it cause this whole thing to become 0? And then our area is 0? And clearly we have an area. We see it. And so that's what, again, makes the problem a little extra difficult, having to recognize that domain. We're going to find that it doesn't matter which value of X we have as A over radical 5 or negative, because it's going to give us the same area. And so if we only have one critical number, you guys, it's going to be our value that's going to give us our maximum. And I'm not going to make you guys justify that. The only thing that you have to do is physically find this area for me. And that's just a matter of going into your area equation, take the X out and replace it with A over the square root of 5, square that A over square root of 5, and you get A squared over 5, right? And I suppose that there's nothing wrong if we left our answer like this. Because we're all together tonight, I'm going to have us simplify this. It just takes a couple of seconds. It's not a big deal. Let's kind of write this as a single fraction. So the 2a over the root 5 will go together. Looks like I can combine these into a single fraction. I promise I'll do the arithmetic right. A squared minus 5a squared would be negative 4a squared, right? Squared. And then if I actually square out that right side, I get positive 16 a to the 4th over 25, which then I could call this what? 32 a to the 4th over 25 radical 5, I guess. And I want to make sure, let's see, do I have this? Yeah, we'll just call it 25 radical 5, I suppose. The other option is, I guess I could rationalize the denominator and multiply the top by radical 5. And then I would have to multiply the bottom by radical 5 as well. And then I get 25 times 5, which is 125. Either of these two answers would be acceptable. Okay. And I kind of want to congratulate you, because you have 3 CMLs that have 32 problems. I'm grading this as the hardest one. I'm classifying that this is the hardest problem. And there's a big jump, in my opinion, to the next one. And so I knew that this was going to be asked tonight. I had no doubt that it was. And I knew it was going to take a while to explain it. So, okay, let's go ahead and move on. And if anybody, again, if you have any questions about this, feel free to throw it in the chat, DM message or otherwise. But we'll go ahead and move on to a second problem as soon as I hear one from you. Probably scared off now, aren't you? No more. Two of the number 8s that you have are optimization questions, which is what we're just getting into in the course. So I get it. So 2020, so that would be the previous one. That's an inscribed rectangle, kind of similar to this problem. Or no, I'm on the wrong one. No, this is the one that finds A, B, C, D, right? Nolan, is this the one that you're looking at? This is actually a great question in that it has a lot to do with what you guys are studying right now in the class. So it says, determine the coefficients so that this curve, ax cubed plus bx squared plus cx plus d, would have a relative minimum at 2, -10 and a point of inflection at 0, 6. So start thinking about relative minimum. Relative minimum can only occur when the derivative is equal to what? And the answer is 0. So why don't we take the derivative of this f of x? Don't worry about the a's, the b's, and the c's because they act as constants. So we would have 3ax squared plus 2bx plus c. Now, remember what I said. The derivative has to equal 0 at the x value where your minimum occurred. So what is it that you guys will plug in for x? 2, right? So f prime of 2 has to equal 0. You're using the definition of a critical value. And so you're going to be able to actually solve something here. You're going to plug 2 in for the x. So you're going to get 3 times a times 2 squared. So that would be 12a. And then you're going to plug 2 in for the x and get 4b. And then you're going to use your plus c, and then you're going to get 0. And there you go. All you got to do, guys, is find out what a, b, and c are. Well, that's a problem, isn't it? Because you can't solve an equation that has more than one variable in it. So put that off to the side, and I think we're going to have more equations that are going to join him. Do you guys see what's happening now with the point of inflection idea? How it uses the same principle? Points of inflection are tied to the second derivative. So we take f double prime. And so when we end up doing that, we get 6a x to the first plus 2b. Now you have to admit that it was a little bit easier to take the second derivative, and we did lose the c, which is a good thing. But once again, the only time that you can get a point of inflection is if at the x value where the point of inflection occurred, your second derivative is equal to 0. Okay? I know you might be thinking, well, what about this negative 10 and that 6? We don't use them yet. Okay? So if we solve this equation here and we plug 0 in for x, we're going to get 0 plus 2b equals 0, which, ta-da, what does that mean? B is going to be 0. And you guys can lock that in. So even if this is all that a student would know how to do for this problem, you could get half of a point, right? This question's worth 2, so I would award a half of a point for each of those blanks. On the actual CML, you have to have all 4 of them right for the competition for it to count. So there's no partial credit, unfortunately. I will give partial credit, though, for the grade that you get for the class. So how do we get the A and the C then? And for that matter, the D? Well, it has nothing to do with calculus, you guys. You see that relative minimum? That has to be a point that lies on the function. So what does that mean that you can do with that ordered pair? And if you're thinking, plug it into the original, you're thinking the right thing. Okay? So I'm going to say, let's use 2, negative 10 in the original f of x. So that means replace the x with 2, and you'll get 2 cubed, which is 8a, plus 2 squared, which is 4b, plus 2 times c, plus d, and that's going to equal negative 10. Okay? And yeah, you guys are right. The b is already 0, so I could have just gotten rid of it altogether. So I have this equation. Okay? Only bad thing is it still has an A and a C and now a D in it. Well, let's be patient because don't we have another point that we can do the same stuff with? Isn't a point of inflection also a point on your graph, on your function? So let's use 0, 6. And if you kind of look ahead, by virtue of the fact that x is 0, that's going to wipe a lot of these things out. In fact, can you guys see that as fact? D has to be 6. So what that means is we can go back to this equation, replace the D with 6, okay? And remember this guy up here? I think I'm going to bring him in here now. And we knew that B was 0. So I guess I could say that 12A plus C equals 0. Maybe I'll write this over here. 12A plus C equals 0. And you guys don't have to knock yourself out to solve this system of equations, right? I think we could probably use substitution, right? Is it pretty clear that C is negative 12A? So then we can rewrite the top equation as 8A plus 2 times negative 12A, which would be negative 24C. I'm sorry, negative 24A. Defeats the whole purpose. And then I'll subtract the 6 over to get negative 16. 8A minus 24A is kind of conveniently negative 16. So A is 1. So we can lock A as 1 in. We know that D is 6. The only thing I'm not going to do, guys, I'm not going to tell you what C is. I'm going to make it a big mystery and make you find the C, but it's going to take you 2 seconds to do that. So, okay. So hopefully that helps out. This is a hard problem. I don't think it's as difficult as the one that was previously asked. I like that this problem has a lot to do with what's going on in your class right now. But that's how you would solve it. Okay. All right. Who's got next? Don't be shy, guys. You're all looking for that C right now, aren't you? That's what you're doing. If you're still looking for it, you're probably working too hard. It's right here. Toss that A in there. Again, if you're wondering like how these get scored, Mr. Meunier might do his a little bit different, Nolan, anybody else that's in Meunier's class. But I tend to have you guys, we have a dice roll and 2 are selected at random. However, there are certain bonuses that you could get on certain faces of the die. Like there's a dice that has a side that says class gets to choose. So we vote, and whichever CML has the most votes is the one that we score. Also, there is a side that says automatic 10 on one of the CMLs. So, all right, I got 2 requests. So that must be a big deal for 2021 problem 7. So that would be up a few years, and I'm assuming it's this one right here. Is that good? Okay. So f of x is your favorite function in the world, a piecewise function. Find the values for a and b so that this guy would be differentiable at 3. All right. This goes way back, guys. This goes a little bit farther back into Unit 2. So one of the things that maybe I would think about is the problem has the word differentiable in it. So maybe we should take the derivative of this piecewise function. And we're allowed to. I know that it says that, well, maybe it's not differentiable, but that's our job, right? Our job is to find these values that will make that happen. And remember what I said to you long ago, piecewise functions are very tricky to work with sometimes, but one of the easiest things in the world to do to a piecewise function is to take its derivative. You just take the derivative of the top. That will give you 2ax. By this time now, 3 problems in a row, you guys have taken derivatives of things that have a's and b's in it, right? Welcome to the CML. The derivative of the bottom would be 3b x squared. And we can keep these restrictions. I'm allowed to keep the inequality here underlined because I'm working towards making this differentiable. And basically, if you want to do this with showing minimal work, you plug 3 in for x and you set those two things equal to each other. That's what you do, right? But you have to do that with purpose. Like if this was my class and I wanted you guys to show work, this is what you would do. Find the limit of f prime as x approaches 3 from the left, which means you're plugging 3 into the bottom part, which is 3b times 3 squared, which is 27b. And then if you're taking the limit as x approaches 3 from the right of f prime, you get 2a times 3, which is 6a. Like that. Okay? Now, in order for this thing to be differentiable, those two things have to be equivalent. Guess what? We can't solve that because they have a's and b's in the equation. If only we could come up with another equation that had an a and a b in it. Doggone it. What are we not seeing here? The fact that f of x is differentiable, what does that imply? And if you don't have to say it, you don't have to type it in the chat. I want you to think about it. And I wouldn't be surprised if 2/3 or more of you, and maybe all of you, are thinking the right thing. In order for a function to be differentiable, that function has to be continuous also. And so what you have to do is plug the 3 in for x in the original function and set those equal to each other. In other words, you're finding the limit of the original. Okay. And just so you know, on the actual CML that you guys will take Friday, you do not have to be as meticulous with the amount of work that you show that you do for the ones that you're doing on practice. All right. The reason is that I know that you're working by yourself. I could monitor you and proctor you in the classroom. So you can be sloppy with your work. You can work a little faster because you do have a time limit. And so, you know what, guys, you're not going to write these limit statements. Don't do that on the day of the CML because it's going to take too much time. Just plug in and get ready to go. 9a plus 5. What is this, guys? 27b plus 10. And what do we know about those two things? They must be equal. And so for the second time on the CML, you have a system of equations. And I don't know if any of you have any interest in this. If you tell me in the chat, I'll help you. I can teach you in 30 seconds how to solve a system of equations on the Inspire. It's quite easy, okay? If we don't do it on the Inspire, you're probably going to do what? I don't know, guys. Is it substitution? No, not substitution. We want elimination on this one because we got 27b for both. Let's do that. So I could subtract 27b over in the top equation. I would subtract 27b over in the bottom equation, and then I'm going to move the 5 over to the right. And then I think I want to subtract these, right? That's the only way I can get the 27b's to cancel. So I would get negative 3a equal negative 5. Are you kidding me? This is going to have fractional values. I didn't sign up for that. A is 5/3. And then are you guys okay if I leave it to you to find B? Okay, B is going to be a fraction. It's going to have probably a 27 in the denominator maybe, but you're so close, right? You can find it just by working through this. Okay. Since we've mentioned it, do you guys want me to show you this real quickly? If you ever want to solve a system of equations on your TI Inspire, all you have to do is go into Menu, Algebra, and we could do option 7, solve system of equations. There's many other ways to do it. And I won't say linear, I'll just do the first option. But basically, it's just going to ask you, okay, how many equations do you have? Well, we have two, and it's going to ask you what are the variables. You can change them to X and Y, but we might as well say A and B. It says variables have to be separated by commas. Hit OK. And basically, it gives you the template, guys. Oh, is my A? This is going to be a little problem, isn't it? Let's pretend that that A is not bold. I'll show you how I'm going to fix that. You guys know why that A is bold? Because I had it as a slider. It's going back to that. So I'll have to delete that out. But anyhow, if you remember those equations, I'm kind of manipulating them so that I got the A's and B's on the same side. So I had that one and I had this one. Now, the problem is this is going to give away here in a second. Once I fix this, this is going to give away the answer. That is not the answer. Please understand that is not the answer. I have to delete my variable A. Okay. Now I can go up here and it won't lock A in as being, what did I have A locked in as? Whatever this was, but now it's disappeared since I deleted the variable. So now I can get my answer, and that's not even right. What the heck's going on, guys? What did I do wrong? That is not what we have. 5/3 should be our A. Did I type in the equation in wrong? I probably have to look. I'm just going to say 6A equal 27B. So let me just retype this the way that 6A is 27B. And then the other equation was 9A plus 5, 27B plus 10. 9A plus 5. 27B plus 10. I'm going to double check, you guys. That's what I had. Okay, now do I get the right answer? Yes, I do. I must have, I read this off of my paper here, and I goofed up somewhere with this. That's still going to give me 5/3 though. 9A minus 27 equal 5. 6A minus 27B equals 0. I'm not so sure. Oh, I forgot my B, right? How come you guys didn't tell me that? I forgot the B here. Now we're good. Now we're good. Okay. Bonus content for showing up tonight. How to solve system of equations. All right, who's got next? 2021 question 2. I always love it when somebody asks a question that's not a number 7 or a number 8. Generally speaking, they're going to go a little faster. So, okay. So it says the graph of which of the following has y equal 2 as an asymptote. And so what you're going to have to do here, you guys, is you're going to have to remember, first of all, what kind of an asymptote is a y equal, right? So that's the first line of thinking. Y equals are horizontal, right? They're horizontal asymptotes. Okay, what do we go from there? From a calculus standpoint, when we were talking about horizontal asymptotes way back in, yes, Unit 1, what is the calculus concept associated with finding a horizontal asymptote? And that would be a limit as x approaches, what is it? Infinity. Or maybe when x approaches negative infinity. Third and final thing, what is the super shortcut way to find the limit as x approaches infinity? And I don't mean L'Hopital's rule, because L'Hopital's rule is not nearly as fast as the other thing that we learned. Remember how you just look at the highest degree x in the top and, oh gosh, this is tricky, the highest degree x in the bottom? Came there, right? and you divide their coefficients if those two exponents are the same. And so the coefficient of x cubed is 8a in the numerator. The coefficient of x cubed in the denominator, be careful, is negative 2a. What does that divide to make? Negative 4. That's the horizontal asymptote for the graph in part A. Is that equivalent to 2? No. And so what you're going to want to do, guys, is keep following that process, and you should get an answer. And I know that there are some people, there's only 12 in the room, but somebody in here might be asking, what does nota mean? None of the above. So sometimes the CML uses that abbreviation. And you know what, guys? Have fun with that, because you're going to have friends tomorrow asking, oh, dude, what was this nota? Mess with them. Tell them it stands for, I don't know, make up something that's clever, right? You know, you're the ones that were here tonight sacrificing your time. You deserve to have some fun with people. So hopefully you guys will be able to answer this. If you haven't already, I think the answer shows up pretty quickly, if I'm not mistaken, right? Again, only compare the term with the highest power on the top and the bottom. You can ignore the other one. Okay, I'll stand by for another question. We're going to keep going till we get to 8:30, and then we'll just kind of see how you're feeling. If you want to throw another quick small one in here, I know working with me during the day is already hard enough, and then spending another hour with me at night is not the funnest thing in the world to do. But sometimes you have to go a little bit above and beyond when I'm asking you to do these really difficult things. And there's nothing that I ask you to do all year that's any harder than the CML practice. It's going to make the AP exam look like chump change. All right, we're going to go to problem 3. By this time, I'm guessing that you guys are probably hoping that we grade the 2021 AP CML, because you've asked several questions over it, so you're probably going to get a good score on it. So it says the line tangent to the curve y equal f of x at x equal -2 is going to pass through these 2 points. Find f of -2. Seems harmless enough, right? Maybe having a picture can be helpful. I'm not saying that you have to have a picture, but if I were to put a picture here, -3, -6 would be right about here, right? And -1, 1 would be right about here. The line tangent goes through those points. So I'm just going to like draw like a dashed line. Pretend that's a line. And this is the tangent. It's a tangent line. And it's a tangent line to a curve at x equal -2. So that's going to be like right here, isn't it? Ish. And so there's some curve. And guys, we don't know what it looks like. I mean, I could pretend like I know what it is. Maybe it looks like this or something, except it would touch, right? It could be on the other side for all I know, but there is some curve that has that relationship. Okay, so the big question is, how on earth do you start a problem like this? Well, would it be helpful to know the slope of that tangent line? I mean, it seems like we focus on finding that a lot in this class. The problem is you can't take a derivative of f to find it, because you don't have the f of x equation. But you do have your algebra way to find the slope of the tangent line, right? And so we'll just do that. The slope of the tangent is just the difference of the y's over the difference of the x's. If this was like a test question in my class, which by the way, you'd all hate me if that was the case, right? I'd give a point of partial credit for coming up with that slope. It's useful. So the next question is, how do we find this y value? this guy like right here, and picture's not drawn to scale, so don't start counting little blocks because that's not going to help us. Okay. Well, I can't do anything until I know the f of x equation, but that's not true. Tell me an equation that you guys do know. Don't you guys know the tangent line equation? Yeah. Pick one of the points. Which one's your favorite, you guys? This one? I heard you guys say that one, right? Because the numbers are a little smaller. Use the point slope formula with that side, with that point. And what is it that you can do with this? I mean, that's the tangent line. What the heck does the tangent line got to do with this point of tangency? I want to find the value on the curve, not the value on the tangent line, unless they actually touch there, and they do, right? So use this when x is -2, and the y value you get there is going to be the same one that you get here. And so this problem is just focusing on your ability to understand that a tangent line will touch a curve at that point that you're interested in, right? A lot of times kids will be mad when they see this problem. They're like, how come I didn't see that the first time? Well, I'll tell you why. It's worded very weirdly. And I didn't have anything in my curriculum like this. Um, it'd have been challenging, but you guys are probably ready for things like this more so now than you were back in September when we were starting to talk about derivatives. Okay, guys, we can keep going if you want. If you guys have stuff to do too and you need to pop out, you're not going to be rude. I know that you guys have other things to study, so you're not going to upset me. I don't have to dismiss you. You can always pop back in and you can watch the end of the recording if you want to. But I'm willing to stay on if you guys got some more questions. Okay, it looks like 2020, number 7. 3 tangent lines walk into a bar. No, that's a different problem. Okay. 3 tangent lines can be drawn to the curve y equal x cubed minus 4x squared from the point -1, 4. Find the sum of the slopes. All right. I got a couple of you. I think Savannah, I think there's somebody else. I think we had worked on this one the other day. And you guys don't have to know what the graph of x cubed minus 4x squared looks like. There's nothing wrong if say you wanted to sketch it. I'm going to doc B all this out. And if we wanted to sketch x cubed minus 4x squared, that's what the graph looks like. The ordered pair, in fact, let me do this. Let me just take this graph. And I know that this is not something that you can ordinarily do, especially the day of a CML. But again, it's not really important. I think if I give you this visual, it at least might make you feel a little bit better. But -1, 4 is up here, right? Basically, what this problem is saying is that you can draw 3 tangent lines, and I don't know exactly where they are. Maybe one of them would be like right like there. Maybe one would be like right there. And guys, I think there's another one that's like it goes like in between that hits maybe the curve somewhere down in here. It doesn't matter what they look like. Okay. All that you have to do is understand that this point up here is the point -1, 4. Nothing is going to change that. But what do you call the points where the tangent C occurs? The point of tangency. We don't know it. Well, what do you guys call things in math class that you don't know? In algebra class, you call something you don't know X. Well, what we don't know is an ordered pair, guys. So what are you going to call it? X comma Y. And so what you can do is you can take the derivative of your function, which is probably the easiest part of this problem, am I right? And say, I know that this derivative means what? It's the slope of the tangent line. Well, what do you know about the tangent lines? They go through that point, -1, 4, and they go through that point, xy. And so just simply do your difference of the y's over difference of the x's. And then for the fourth time tonight-ish, we're going to try to solve an equation that has too many letters in it. So we're going to fix that. Call y something else, guys, in terms of x. What is y equivalent to that has an x in it? And you need look no further than the original equation, because it's perfectly fine to use that because that is the curve at which those points of tangency are happening. So the rest of this problem is A, either just a little bit of tricky algebra, or B, setting you guys up so that you could royally cheat. And when I say cheat, I'm not saying that in a derogatory way. If you're taking the CML and you need to solve that equation really fast, it is not illegal for you to use the solve feature of your calculator. I want you to know that. All right. If we have CAS calculators, by golly, we're going to rely on them. We're going to use them. Okay. Now, what I would like to do is try to push you guys a little bit to maybe not type it in. In fact, some of you could probably solve this just as fast by hand. So let's cross multiply. So this -1 minus x is going to have to multiply by the 3x squared minus 8x. And then I've got this 4 minus quantity x cubed minus 4x squared here. And so if I FOIL this, right, I get -3x squared on the first. The outside is -3x cubed. The inside is plus 8x. And the last is, boy, correct me if I do something wrong, plus 8x squared. Ever since I made that first mistake, I have been checking the chat a lot more often so that I don't waste your time. And then we're going to distribute the negative like such on the right side. And now we just combine like terms, right? Let's get all the x cubes over to the left. I'm going to change my mind. Let's get all the x cubes over to the right. Because if I do that, I get a positive 2, right? So I'm adding 3x cubed over. So he's taken care of. Let's take the what? 5x squared that we have there and subtract it from the 4x squared. So those are done. And then I'll subtract 8x. And then I'll have my plus 4. And now I'm going to solve this equation here. And you guys, what I noticed about this equation, it's not, you talk about a great storybook ending to, as we wind down our first semester. This utilizes one of those topics that we studied in the summer packet, factor by grouping. Those two terms and those two terms will share a common factor once you GCF factor them. Pull out a 2x squared, and you're left with x minus, ooh, I can't pull out a 2. Let's not do that. Pull out an x squared, and you're left with 2x minus 1 minus, what's the common factor there? It's a 4, isn't it? And we're left with 2x. Oh, that's a plus. No, it isn't. Because we have a parenthesis grouping symbol here, that plus gets to change to a minus, doesn't it? Because a negative times a negative is a positive. Now you guys can factor out the 2x minus 1. You've got an x squared minus 4. Okay. Now, here's what I'm going to do, you guys. Okay. At this point, I'm going to leave it to you to solve that equation. Okay. And I want you to keep in mind that you're going to get 3 different x's. Okay. There's going to be a first x, a second x, and a third x. Okay, I think one of them is going to be a fraction, isn't it? Now, that's not your answer. Don't stop there. You are supposed to find the sum of the slopes. Please don't add those x's, because are those x's are slopes? No, those are the positions where the tangent line's being drawn to the curve. Where would you go to find a slope in a calculus class or a calculus problem? How about the derivative? So you would take each of those x's and plug it into this original derivative here. Then those three numbers get added together, okay? And I want to warn you that the final answer to this problem is a fraction. And I'll tell you what, it lies somewhere between like 15 and 25. That gives you a little hint, right? And I don't care if you write it as a mixed fraction, as an improper. My goodness, guys, you could write it as a decimal, and I'll give you full credit as long as it's accurate. So, okay. So hopefully that makes some sense to you. Got another request, same CML, problem number 5. The line y equal 4x plus 12 is tangent to the curve whenever k is negative. Find k. Okay, well, if this line right here is tangent, then what does it mean about the slope of that line? That slope would be equal to the derivative. So let's take the derivative of our y, which is not bad. Boom, done. And you're going to set that equal to 4. You guys, sometimes that's all it takes to get into a problem, is to read that language and just understand what does it mean. But this is a real central idea of calculus, right? Okay, so what's k equal to? I don't know. It's 4 plus 2x. Well, I don't think that that's what they want us to find here. I think they want k to be an actual number. So for the 4th time tonight, 5th time, I'm losing count. We have an equation that's got too many variables in it. Very common theme on the CML. So where would you go to find another equation that had those same 2 variables? In other words, what does a curve and a tangent line have in common? They intersect. And if 2 graphs intersect, what are you allowed to do with them? You can set them equal to one another. Okay. So I don't know if the Inspire will handle. In fact, guys, I think it will and handle this. You just have to call the variables x and k, but it might be just as fast if you just want to use a substitution method, right? I'll do the first step here for you, but I think most of you see what's about to happen, right? You're just going to replace this k right here with 4 plus 2x. And then you're just going to solve this equation. Okay, we can go another step if you want. It's hard to tell if I'm going too fast tonight because I have to kind of gauge my pacing, because I want to make sure we finish the questions that you guys ask. I don't want this to be just about doing 3 problems. We've actually done a pretty fair share of them here, which is good. What do I have here? X squared, the 4x's cancel, right? And then if I subtract the 12, I get -9. Oh, okay. So what is x going to equal? 3 and -3. Now, wait a minute. What did this problem ask us to find? K. So where do you find K? It's a good question, right? And be very, very careful, because just because you have 2 x's does not mean you're going to have 2 k values. Read the fine print of your problem. Okay? And that's going to help you there. All right. If you guys are okay with it, Jack's got one more question. That's the one I was going to end tonight with, if that's all right. And that's going to be 2021 number 4. The reason being too is I don't want the video to be too long so I can get it processed effectively. But you know what we can do too, you guys, is that if you guys have more questions, we can always take some time in class, like before class, after class. I could even stick around a little bit tomorrow at the end. Come in the morning before 8:25 if you got a chance, and I can give you some hints. But tell you what, you guys have come a long way tonight. You're going to have quite a few of these that you're going to be able to score good points on just for your hard work tonight. And I really do appreciate that. So the last problem tonight, the limit as h approaches 0 of this maniacal limit statement. First of all, do you realize that you're not allowed to cheat and just use your graphing calculator for your practice CML? Because you got to show work for this. So if you at least made a table, if you sketched a graph or something, I would take that. But what I think you have going on in this problem more than anything is maybe it's another definition of derivative. What do you guys think? Maybe, I don't know. Could be. But there's another thing that you guys have at your disposal. What's the most recent thing that you guys learned that really helps you find limits pretty fast? L'Hopital's rule. And I think that this is a great application of L'Hopital's rule. Okay? So first of all, let's make sure that we get 0 in the top and 0 in the bottom. So if I took the limit as h approaches 0 of the cubed root of a cubed plus h minus a, and if I turn the h into 0, the cube root of a cubed is a, yep, I get a minus a. And the denominator is obvious. So that means you can use L'Hopital's rule. Okay, what was L'Hopital's rule? L'Hopital's rule says that if you take the derivative of the top and divide it by the derivative of the bottom, you can then plug in your value. The question is, who is the variable in this problem? And I'll give you a hint. It's not x. Thanks, right? What's changing? Look at the limit. It's h, right? So when you take your derivative, you're going to do so with respect to h. So if this radical was having a dream, he would probably like to be written like this so the derivative can be taken easier. So I would have 1/3 out in front, a cubed plus h to the negative 2/3. And then check it out, guys, the chain rule, easy peasy. The derivative of a cubed is 0, not 3a squared, 0. The derivative of h is 1. The derivative of a, 0. Let's get that 1 out of there, man. We don't even need him. And then what's the derivative of h? 1. Can we plug in 0 for h now? We're going to try. And we get 1/3 a cubed to the negative 2/3 power. And then does that match an answer choice? Not yet, but if you keep working on it, multiply exponent to exponent, maybe look at that, maybe rearrange things a little bit, and it will be one of those answer choices, I promise. And I'll give you a hint. The answer choice is the first letter in the word Djibouti, a country in Africa. There you go. Geography lesson tonight that I just threw in a little extra. You guys, I want to thank you so much for hanging around tonight. I know that this is tough. You guys did a really good job. You had a good hour and 15 minutes, 75 minutes of hardcore, hardcore CML action. And so I'm really proud of you. And like I said, I'll be around tomorrow if you guys have um, any, issues with, more problems that you want to solve. I am going to tell you that it's not likely that these are going to be graded on Friday because we have to do the CML Friday. But I'll tell you when we're going to handle like when they're going to be collected and all that when we get back together. It's not going to be tomorrow. All right. So um, tell your friends, I guess. And whatever we did tonight, if you want to share with friends, that's fine. That's really your call. So CMLs go into the enrichment category. Okay. And remember, in my class, you guys have been getting a lot of enrichment points. You got a few when you did that website with the graphs of F and F prime. You got 3 points the other day when you did your foldable. I know period 7 still has to get those points, but I'll give them to you. Guys, we're going to do something in class tomorrow with some flashcards that you're going to get some 3 easy points. So I've kind of stacked that category up a little bit. And remember, enrichment's only 5% of your grade. Okay. And also, did you guys know that you get 3 bonus points when you take the first CML? So the lowest score that you can get is a 4 out of 10. So set your sights low, right? That's well, I guess if you get nothing right, you could get a 3 out of 10. But it's very likely that you guys are going to get more than just 0 points on it. Okay. But if you go above a 10, you go above a 10. So, okay. So hopefully that helps out. So I'm going to go ahead and cut out the recording here so that I can get this processed. But for those of you that are watching on demand, I certainly thank you guys for tuning in. I hope that this was helpful. And if you think it's something that we can do again in the future, I'll be more than happy to do that.